Hi, this is Todd June with OP-TEC, the National Center of Optics and Photonics. Today let's look at Lab 2-6, which is diode lasers and operations and measurements. Remember, we'll be needing to use our laser safety glasses. I'm using the PL-MICO system for my diode laser, and the purpose of this laser lab is to measure the diode current versus its output power. We're also going to adjust the temperature of the laser diode and see how that affects our spectral output. We'll be measuring beam characteristics and be using the power meter, beam profiler, and a spectrum analyzer. As we get started on the first part of the lab here, I just want to show I have a diode laser here with a couple of beam shaping optics so I can collect all the energy. And I will be adjusting the drive current on my laser diode and measuring the optical output. We've done this before, but we just want to reinforce this idea is that once we've reached threshold current, is we should see an output, and as we increase current, we should see a linear relationship as we move through this lab. I have my diode laser set up and we're looking at the beam profile. I want to move my sensor back, but you look over to the left, you can look at the major and minor axes and it's about the same diameter. But as I move my sensor back, you can see that it changes. So one of the things to look at the diode laser is that what happens to the ellipticity and the divergence, and compare the advantages of a diode laser versus a helium neon or some other laser you want to look at. Now we've replaced our diode laser with a helium neon laser, and we're looking at the beam profile. What you'll notice here is a nice Gaussian curve, and we're looking at the near field information, and you can look at the major and minor axis up here at the top part of the screen, and you can actually use these are my 1/e² points, and actually use that for your beam diameter, and you can record that distance from your laser aperture. We're going to move this all the way down. And this is a way you can measure your divergence. You want to measure the difference in the beam diameter as well as the difference in the distance. And you can use the information that you've gathered from your beam profiler to calculate your divergence. As we move towards the spectroscopy portion of our lab, we want to look at some additional equipment. We have a spectrum analyzer by Ocean Optic, and I have a USB cord attached to my computer so I can acquire the signal. And the other portion of the spectrum analyzer is attached to a focusing optic, and the focusing optic is collecting the output of the laser. And I've tried to attenuate that signal using a neutral density filter. So we want to take all that into consideration when we're gathering our data for our wavelength. And we should be able to pinpoint the exact wavelength of our output laser by looking at our computer screen. This portion of the lab also looks at adjusting our laser temperature. And this particular laser, I can adjust it from 5 degrees to 35 degrees Celsius. And we'll be looking at about 15 different data points to collect and see what happens when we look at changing the temperature, how that shifts our spectral line. What you're going to see is you're not going to see a great difference, but you will see about 10 nanometers of change from about 5 degrees Celsius to 35 degrees Celsius, depending on what laser you're looking at.